Hello guys, welcome to the class of software engineering. In this session, you will learn about the architectural styles for software application. Let's start with the very first type of architectural style, data flow style. Data flow style is characterized by viewing the system as a series of transformations on successive pieces of input data. Data enters the system and then flows through the components one at a time until they are assigned to output or a data store. Batch sequential style. The processing steps are independent components. Each step runs to completion before the next step begins. Pipe and filter style emphasizes the incremental transformation of data by successive components. The filters incrementally transform the data, entering and exiting via streams. Call and return style has been the dominant architecture since the start of software development. It is basically has main program and subroutine style, which decomposes a program hierarchically into small pieces, i.e., modules. Typically has a single thread of control that travels through various components in the hierarchy. Here upper modules call lower modules and lower modules return some values after executing. Then comes layered system. In layered system, assigns components to layers in order to control intercomponent interaction. Only allows a layer to communicate with its immediate neighbor. Assigns core functionality such as hardware interfacing or system kernel operations to the lowest layer. Then other is object-oriented or abstract data type system. Emphasizes the bundling of data and how to manipulate and access data. Keeps the internal data representation hidden and allows access to the object only through provided operations. Data-centered style refers to systems in which the access and update of a widely accessed data store occur. Here, a client runs on an independent thread of control. The shared data may be a passive repository or an active blackboard. A blackboard notifies subscriber clients when changes occur in data of interest. At its heart is a centralized data store that communicates with a number of clients. Clients are relatively independent of each other so they can be added, removed, or changed in functionality. The data store is independent of the clients. Client-server architecture is very popular in distributed computing and is suitable for a wide variety of applications. This style features two major components, a server and a client. These two components interact with each other through a network connection using a given protocol. The communication is unidirectional. The client issues a request to the server, and after processing the request the server returns a response. There could be multiple client components issuing requests to a server that is passively waiting for them. The important operations in the client-server paradigm are request, acceptance, client side, and listen and response, server side. Then comes the peer-to-peer model, suitable for highly decentralized systems, introduces a symmetric architecture in which all the components, called peers, play the same role and incorporate both client and server capabilities of the client/server model. Each peer acts as a server when it processes requests from other peers and as a client when it issues requests to other peers. With respect to the client/server model that partitions the responsibilities of the IPC between server and clients, the peer-to-peer model attributes the same responsibilities to each component. In two-tier architecture, the system is partitioned into two tiers, which are located one in the client component and the other on the server. A two-way interaction in a client/server environment, in which the user interface is stored in the client and the data are stored in the server. The application logic can be in either the client or the server. The client is responsible for the presentation tier by providing a user interface. The server concentrates the application logic and the data store into a single tier. The server component is generally deployed on a powerful machine that is capable of processing user requests, accessing data, and executing the application logic to provide a client with a response. The three-tier architecture separates the presentation of data, the application logic, and the data storage into three tiers. A classic example of three-tier architecture is constituted by a medium-size web application that relies on a relational database management system for storing its data. In this scenario, the client component is represented by a web browser that embodies the presentation tier. The function of the interface is to translate text and results understandable to users, whereas the application server encapsulates the business logic tier, which coordinates with the application, processes commands, makes logical decisions, performs calculations. It also moves and processes data from surrounding layers. Database server machine, possibly replicated for high availability, maintains the data storage. Model View Controller is a widely accepted and adopted pattern. Let's start with model aspect of MVC. It is the central component of the pattern. It is the application's dynamic data structure, independent of the user interface. It directly manages the data, logic and rules of the application. Now view is the representation of information such as a chart, diagram or table. Multiple views of the same information are possible, such as a bar chart for management and a tabular view for accountants. And, controller accepts input and converts it to commands for the model or view. In addition to dividing the application into these components, the Model View Controller design defines the interactions between them. The textbook Pressman, R. Software Engineering, a practitioner's approach. McGraw-Hill is referenced while organizing these slides. Hope you all enjoyed the session. Happy learning and thanks for joining us.